Good afternoon. So today, this will be our topic, power transistors, or particularly power BJTs. So kailangan mo dahil classic power transistor. This is supposed to be power BJTs. So if you have your notes with you on power BJTs, would you remember uh, or distinguish the differences between power BJTs and regular BJT? Nabala sa inyong notes? Regular BJTs versus power BJTs. Ano sa'yo nasa inyong notes? Or base yung mga characteristics ng inyo na take note of are common to both. No? So, namagin slight differences. Pero, basin, no? Maybe nasa inyong notes laan, at least kamay na lang atong need gid explain to this afternoon. If indeed, nadaan dito. Okay? Check na sa inyong e-learn, be. Of course, ang symbol, pareha naman, no? Pareha ang symbol sa power BJT and regular BJT ang nagyapon ng NPN. And iyan nagyapon ng PNP. Collector, base, emitter, collector, base, emitter. So, nag-gets ko ni answer si NC ba? Kaya isa lang. Wait. Wala. Kuan. How about yung previous pa yun? No? Previous. Katong nangay ko og kuan. Notes regarding notes regarding power devices in general, no? Katong kauban sa switches, no? Tabi. Kinsa man akong pilion dire. Kanang power semiconductor devices, no? Part man diha ang power BJT. Namoy na take note na differences ni power BJT compared to regular BJT. What about breakdown voltage man ends? It's higher, okay, of course, yes. Logically, ang on resistance is higher, lower? Higher gyapon. Okay. Faster switching, bigger power capacity, okay. Okay, naisa si Carl, quasi-saturation. So that's a term na new. Okay. Na-define mo na diya, Carl, quasi-saturation. Better thermal resistance, okay. Now, of course, generally speaking, compared to regular BJT, di magid siya dili geared to siya pwede for high power applications, okay? Especially when we deal with voltages above 1K or even above 100K, no? Even above 100K. And currents above, I don't know, 5 amps or 10 amps. Higher than that, no? So di gito pwede tong regular BJT. So pwede na to siya for amplifiers, no? Amplification, small signal applications. But for applications such as katotong na mentioned before, like power conversion, no? Power conversion, power control. Okay. All the other characteristics of regular BJTs, kung i-compare sa power BJTs, mas higher good, no? Higher, based sa inyo hang na mention, higher breakdown voltage, higher resistance, higher power capacity, yes, faster switching, and that. So I guess it's not really that difficult, no, for us to understand the operation behind BJTs or behind power BJTs. Okay, kabalo naman to before sa how regular BJTs work. Pero at least kato as amplifier naman to, even as switch, no. So kana for the most part ang atong kuan usage sa power BJT is switching lang yun, no? Especially with these applications in mind, power conversion and power control. Okay. So na-mention si Carl na term, quasisaturation. That's a term na atong ma-touch later. Okay. Maybe mag-focus ta this afternoon sa mga major differences between power transistors compared to the regular power BJTs compared to regular BJT. Okay. So this one, power semiconductor switches constitute the heart of modern power electronics. Not necessarily power BJTs. Okay, power semiconductor switches, of which BJT is just one. No, we also have MOSFET. We also have IGBTs. And thyristors, and so on and so forth. Okay, so power semiconductor switches constitute the heart of modern power electronics. Depending on the application, such devices should have larger voltage and current rating. Kani? Kasi yun sa parang klaseng power semiconductor device, mag-iahang malag main, no, nga feature. Even sa power diode that we've encountered before, larger voltage and current rating. Faster switching, instant turn on, turn off characteristics. If dili, no, diha magikan ang iyahang if dili kibali instantaneous ang pag-turn on, turn off, we know na diha magikan iyahang power dissipation, right? So di ba? If we want our electronic devices or power semiconductor devices to not consume power, dapat paspas iyahang pag switch on and off. Okay? Sige lang, I think ma-cover gyapon na nato na later, at least ma-review ta. Kaya parehara mo gud, no? Parehara ang itsura sa current in terms of time, no? In terms of time, ang current of voltage na graphs sa transistor sa kuan, sa diodes, no, with minimal differences. Very low voltage drop when fully on, zero leakage current, and ruggedness to switch highly inductive loads. Okay, highly inductive load because most of mga loads are not only resistive but inductive, okay? Especially when we talk about motors. Okay. Maganda ang isa pod sa feature sa power electronic devices is having in mind ang loads kay DC or AC motors, which are measured in terms of safe operation area. Kaya isa pod ni siya sa atong dapat take note of safe operation area. Safe operation area. Okay? Di kay tagamay na kung kuan lang, no, kung regular BJT. And reverse bias, second breakdown. The same with regular BJT, we do not really mind ang reverse bias na characteristics, no? But important gapon na siya because, let's say for example, just to somehow review, no? Or somehow analogy lang siguro ni. Remember before atong topic on rectifiers, no? Itong bridge rectifier. Ayan na. So for duha man ka klase nga cycle, positive half cycle, negative half cycle. Ato naman ginamind is ang capability sa atong kuan nga maka-produce siya og output ana-ana. Okay? Because assumed man ato mag-assume nga di po diyan nakadako ang atong input nga makaguba sa sa diode, no? But even if in the positive half cycle, okay, during positive half cycle, or no, I mean, positive half cycle. Sa positive half cycle, only asa ba nga mga kuan mo kuan ani? Di ba? To only one pair of wait lang sa ha. Sakto ba na kung pagto? Magdili ang kuan output. Nagang V out, no? So only load ni siya dili load. So at an kuan bali niya akong isa. Sige lang. So, during the positive half cycle, only one pair of diode naman ang on. No? So, in this case, this diode and that diode. So, how about the two diodes? Maka-reverse bias. Okay? So, during the positive half cycle, denoted sa katong kaning current flow nga blue, duha lang ka diode ang turn on. Ang two other diodes kay off, no? Or naka-reverse bias. But we should also consider na even if naka-off siya, the applied voltage should not be greater than the power rating, no? Power rating of the diode nga naka-reverse bias. No? This one and this one. So the applied voltage should not be greater than the breakdown voltage. Okay? Wala kayo nato na consider, di ba? If you remember sa Lex 1, Lex 2, wala kayo taga-mind of power. Brought up lang sometimes, but dili kayo. Good. So, during the positive half cycle, the other two diodes kay naka-reverse bias, and dili sila maguba assuming that their breakdown voltages are greater than the applied voltage. No? So, the same with, no? Analogy na to. The same with power transistors. We should consider this time ang reverse bias voltages or reverse bias second breakdown voltages. Okay? Hindi na siya pwede i-ignore. Okay? Well, kung i-ignore natin na siya, then makakause na siya sa pag-breakdown sa device or sa transistor if wala na consider. So, high temperature, capability, high reliability. Okay, so these are its applications. So these are some physical photos, no, of power BJTs. Okay? Like siya sa katong regular lang BJT, discrete component, nga makita nato sa lab. Yan lang. Okay? So these are powered BJTs in different packages. Lahi pod ni siya. Lahi pod ni. So these are all BJTs. So this is a model, no, of what what are the layers of a power BJT looks like. Notice the difference, no, between this one, the image on the left, and what we know of before sa BJTs. So yung main difference ka, yun, yung ma-observe, no? N, kay unsa nga N, nil. Kay na ay N negative, no? Before, we only know of BJTs as ingani, either PNP or NPN, no? Na 3 layers. So, kanay upat na ka-layer. Pero, NPN gyapon, no? N, P, and even though duha ni karasi nga N magyapon. So, NPN, gyapon siya nga device, but there are two types of N layers sa collector. Okay? We have the N negative and N positive. N minus or N plus. Yan naman na siya pag-read. What's the difference between the two? The one that was positive nga exponent kay these are heavily doped, no? Heavily doped na kuan layer compared to the other one, no? Lightly doped. So collector ni siya from here to here. It's a collector. This is the base. And this little one is the emitter. Okay. So nada ang iyahang mga measurements, not doon to scale. Okay. For visual lang. So most of our electronic appliances use NPN transistor because electrons move faster than holes, and therefore NPN transistors have considerable faster commutation times or switching times from two states compared to the equivalent NPN transistors. So this is what we call a vertically oriented BJT. Vertically oriented. So tungod ani nga kuan, because the power BJT has two layers for the collector, na isang lightly doped na isa ka heavily doped, na siya mga effects, no? Na siya mga effect. One of the effects is a much lower current gain or beta, no? So one of the effects is lower current gain, beta. So normally, because beta is lower, high voltage BJTs typically have low current gain, and hence Darlington connected devices are used. Na-encounter natin ni before, Darlington sa LX1 or 2. Darlington connection. Ang iyang kuan is ingani. Wala pa, okay. So, aside from the diode, no? Aside sa diode, muna yung Darlington connection. So, nailain nga type of Darlington connection, muna na siya. And the purpose of that is to increase beta. Okay. The Darlington connection will have a total gain of beta 1 plus beta 2 plus beta 1 times beta 2. What's the purpose of diode D1? Diode D1 speeds up the turn-off process by allowing the base driver to remove the stored charge on the T2 base. Remember before sa kuan, diode circuits, no? what's the proper term of this one if a diode is connected sa aning way and serves a specific purpose? Starts with letter S. Dagan siya terms din, no? So, isa lang nag-start sa letter S ay yung mga terms. If you could remember, we call the diode as a snubber. Diode, no? Snubber. It serves as a pathway for katong sa snubber circuits, katong snubber sa diode circuits, pathway siya para sa inductor, no? Inductor current. Para dili maguba ang diode. Here, it's not really, no, dili man inductor yung gina-serve but ang transistor. But remember, no, na during turn off, okay, let's say for example, T2, no? T2 goes now from on to off. Yun siya automatic mag-off gyud, di ba? Sa tong graph, remember, napay di ba pwede man natin siya ma-visualize as na a diode diha. So this explanation works the same. Remember na dili man siya automatic mag-off, right? Napanay gamay nga leakage nga negative current because of the stored nga charges. Kaya naman na siya yung mga internal capacitances. No? So, no matter how small, nagyapon. So, para mas speed up ang pag-discharge sa power inside the transistor, one ang purpose aning snubber diode. No? Snubber diode. Para dito na mapadalong, no? Para mapapaspas kibali ang pag-turn off ni transistor 2 in this example. Diode speeds up the turn off process by allowing the base driver to remove the stored charge in T2 base. Okay. So next slide. Quasisaturation. Before that, mabut there, no? I'll just conclude with this one. No? For power BJTs, it requires a large blocking voltage not in the forward bias state but in the off state. No, it needs ang implication is it will have a larger breakdown voltage. So it will require, or it should have, a large blocking voltage in the off state. Okay, switch man siya. If it is off, remember sa switch, if the switch is off, remember that the voltage across it, okay, remember that the voltage across an off switch is the voltage of the source. But unlike the mechanical switch, no, nga could withstand large amounts of voltage, hindi man siya electronic device, mechanical man siya. So if this is an electronic device, then transistor man yun, no? In the off state or in the cut-off region, dapat maka-withstand siya o dako pod nga input voltage o natong gusto mahitabo o manang iyang main nga purpose, no? And mao po na usually ang input high power or high voltage, no? High voltage nga sources. In the off state, it should withstand, no? It requires a large blocking voltage in the off state. In the on state, dili kayo big deal ang voltage. Of course, di man po nato i-ignore. Di man po nato siya isaksak o layo na po kayo ng mga values. But in the on state, mas mag-matter iyang current carrying capability. In the on state, it should have a high current carrying capability. So, dire, sa quasi-saturation, before or for regular diodes, I mean transistors, regular BJTs, nanantay tulo ka main regions. You have the active region or linear region, the saturation region, and the cutoff region. Okay. So, for power BJTs, na ikaupat region. And we call that the quasi-saturation region. Such that, ang normal na saturation region is we call the hard saturation. This one, hard saturation. So, the same gamit lang placement, except that in between the saturation region and the active region, natagin na tawag nga quasi-saturation. Quasi meaning partly, no? Not really, but close enough. Malag meaning ana. Malag saturation pero malag dili. Okay, quasi-saturation. Diba? Okay. Kaya active region is definitely linear man linear man na siya nga mga curves. Ang saturation is, kung normal pa siyang BJT, is atong non-linear nga part. So, maning saturation, maning active. But here, ay quasi, no? More siya linear, okay, straight line gihapon, but gamay iyahang voltage, no? Kama siya dire. So, gamay ang voltage na dili pa siya matawag na active yun region. Yan na. Okay? And ang cause ani is katong earlier, no? The presence of this one, the lightly doped na collector. And ay proper nga term ani actually. So ito, drift region ni siya. Collector drift region man ata to. Checks na ako. Yeah, collector drift region. Itong itawag na collector drift region. So because of the collector drift region, of the presence of the collector drift region, na-form ning quasi-saturation region. Ang ato lang timan-an is ingani, no? Isa sa benefits, no? Isa sa benefit nga matag sa quasi-saturation region is a faster, no? Much faster na change of state Okay? And if much faster ang change of state, mas gamay ang power dissipation. No? Just think of it like this. No? So, ang switching sa BJT is cut off to saturation, di ba? Saturation, cut off, saturation, so on and so forth. As long as siya mo labay sa active region. Okay, when it is in the active region, bali, nag-act man siya as amplifier, so mag-consume gina siya power. So we don't want that for our power conversion or power control ng mga applications. So switching from cutoff to saturation. But if the saturation were much closer, diba? If the saturation were much closer, like what's happening right now, if na quasi-saturation, so mas gamay pag yun, no? Mas gamay pag yun ang makonsume na power sa atong switch, sa atong electronic device. Okay? Kay enough naman ang quasi-saturation for it to operate as a switch, no? Not na nga kinanglan pag siya abuton or ipaabot sa hard saturation. So mo na ang no, in a nutshell, it might be confusing, no, nga nang naman na siya diha. But just think of it like this. Tungkol sa quasi-saturation, from cut-off to quasi, mas paspas, no? Mas paspas ang transition kaysa sa cut-off to hard saturation. No? So yan na lang. No? Yan na lang. Naman dito, one explanation day. This region exists due to lightly doped lift layer when the BJT operates at high frequency. It is operated in this region. No? Much better nga i-gamiton or i-take advantage ang quasi-saturation if frequency is vital. No? So, paspas nga switching ang need, ang kinanglan. So, meaning high frequency. So, it's better to use the quasi-saturation region. Both junctions are forward biased, just like the hard saturation. When we say the saturation region, if you could remember from LX1, both the base emitter and the base collector junctions are forward bias. So, what meaning ani? Okay, kung reverse bias, if the base emitter and base collector are both reverse bias, remember, that's the cut-off region. So sa saturation, the base emitter and base collector are both forward biased. And the same with the quasi-saturation region. Naka-forward bias gapon si base emitter and base collector. The device offers low resistance compared to the active region. So power loss is less. So mamo gid atong ultimate yun, no, na goal sa power electronics or sa indus for efficient na transfer of energy. Less na power loss. In this region, the device does not go into deep saturation, so it can turn off quickly. Therefore, we can use this for higher frequency applications. Dapat for higher frequency application. So yan na lang. Let's just think na paspas ang pag-transition from cut-off to quasi-saturation. Yan na, paspas. Di na siya kinanglan mo adtoog normal nga hard saturation. Now, what is primary breakdown voltage, or primary breakdown voltage or primary breakdown phenomenon? So, breakdown voltage, BV/SUS, is the limit for primary breakdown. It's the maximum collector emitter voltage that can be sustained across the transistor when it's carrying collector current. So in the on state, it is carrying collector current, so maximum collector emitter voltage. And kani nga mga parameters, numbers, nani siya sa specs, no, specification sheet. So we don't need to worry as na sila makitaan, ngayon, so this is an example of uh, a power transistor, no? So sa iyang capability at ako magyapon 465 volts man. So ang iyang packaging is the same sa atong normal, no? Normal na BJT. Okay. So of course mas tako siya og power ratings sa man tong page. Nadala. So nadali ang mga absolute power ratings. Gamay rin ang power dissipation, no? 1.1 watts. Ito mga time. Delay, no? These are the turn-on time, storage time, fall time. The same gyapon ng mga parameters atong nakitaan before sa power diodes. So later, sa next slides, kita na tong asa nila bala na to, no, kung asa sa makitaan. So this is an example of a specification sheet, no, for a power transistor. So kato, kani sila dito. Kani sila dito na sa makita. Okay. BV-SUS is lower than BV-CE-O or BV-CBO that measures the transistor's voltage capability when the base current is 0 or negative. Or in other words, this one, when the base current is 0 or negative, in other words, that's the reverse bias, no? So mo ang breakdown voltage or iyahang voltage blocking capability, no? During the off state or reverse bias state, how much voltage could it withstand, no? So that's BVCEO or BVCBO. So dako siya nga consideration when it comes when we talk about power BJTs. Sa regular BJT wala na to na 9 gig, di ba? Another key concept is the safe operation area. Nakoy nakita nga specs nga naani siya gyud, no, kaning mga graphs, kaning specific nga spec kay wala. Wala no. The safe operating area. Wala kay nato gina-consider. I can't remember pod if naba ni siya nga graph specifically sa katong mga small signal na transistors. Pero sa power BJTs is kuan siya, no, big deal. So dapat siya pabalaan kung pilay value. Safe operating area. So we have two safe operating areas during the forward bias. This one, this is the forward bias. And this is during the reverse bias. So in forward bias operation, these are the limits, no, limits of operation, so that our power BJT will not be busted. Okay. So in terms of IC, kanang current, so IC, no, I guess that's understandable. IC max manggid niya ang atong kuan kinahanglan mabalaan para for us to know sa iyahang maximum nga makaayang current. This here is BVCEO. So sa kaning example, pila ang BVCEO? 465, no? Or 800 siguro. Like siguro nga notation gigamit. I think BV susman siguro dapat ni kini isa. So we have 800 on BVCEO. Either 800 or 465. Diba? 465. So, muna siya ang maximum voltage, sa ma-withstand niya in the forward bias. In the reverse bias, wait, VCEO, alagi BV lagi ni. Ang VCEO, dala. The same na gapon. The same na gapon nga value. Whether, sa kaninga particular diode, no? Or transistor, sa kaninga particular part number. The same like VCEO, BV, CEO, 465 volts. No? Reversible. So, during the reverse bias, dilit na gamain, no? Kung pila ang IC kay force reverse bias man. But kung pila ang this one, no? VCEO. Safe operation area. So, next. Okay. So, switching characteristics, no? Observe. This is the load line. No? We've encountered this before. Yung switching characteristics, this is the applied current, IB. And this is the current flow across the transistor. And consequently, siguro sa load pod, IC, and VCE. So, kung kuan pa, ang IB mo na yung atong ginatawag na trigger. No? Trigger current. Because the BJT is, remember that the BJT is a current-controlled current source. So, ang controlling current is si IB. Ang controlled current is si IC. So, IB again acts as a trigger if IB is there, IC will flow from collector to emitter. So, notice the graph. So, kaning mga parameters, monitor atong makita earlier sa specification sheets. T-on, TS, and TF. So, nara na sila sa specs. No? Actually, tanan magiging nga atong kinanan na values, nara magiging na sa specs pod. So, at least, we have that skill na na-gain, how to read specification sheets. So, pareha sila, no? The same na sila o kanang switching characteristics sa diode. No? Nga ang it will take some time pa for current to rise, no? To its maximum level, IC max. And kana pod, no? Sa iyang pag-turn off. The same gapon sa voltage. Voltage does not turn on or off instantaneously, but napaning mga times. And tungod ani, remember before, that because of this, muna ang di magikan ang reason nga nganong na ay power consumption sa switch, no? So the same gyapon with any other load, just like inductive. Ato makita ron mo ni siya ang for inductive load, no? So the same gyapon, no? Nagyapoy switching losses due to pag-rise ug down sa IC ug pag-fall ug pag-rise ni VCE. Gyapon. But ang difference lang diri is si IB, no? Notice si IB na ay reverse. Sa tawag ni ani? Reverse current, no? Just before siya mo turn off si IB, na ay reverse ng current. So one way again to solve this one is to add a snubber circuit para mas paspas ang, I think we've covered this one earlier. Para mas paspas ang pag-flow sa reverse ng current. Kanang lang i-add og snubber ng circuit. So, maniyahang characteristic curve, no? Kung inductive ang load. Now, dire, mauna ni ang isa pod sa main differences between the power BJT and the regular BJT. For the regular BJT, we do not need to design, no? Or di na mag-matter unsa ang driver sa base. Okay, let's say for example, small signal na amplifier or even small signal nga switch, no? Di naman taga-mind unsa nga type of circuit ang mo drive og current sa atong transistor. Di ba? Pwede lagay na diha putang tag op amp. For each sa op amp naka-connect ang atong sensor, no? Dito ang sensor. So siya, kung regular pa nga kuan, plug and play. But it's not so, no, with power BJT devices. Power BJTs. The base drivers should be properly designed, no? So we have numerous BJT base driver circuits. These are just two examples of base drivers or base driver circuits. Okay? So the first one, our transistor na here, naga-control sa load for whatever load man iyang gina-control, no? Example na ang load is this transistor. So maniyahang base. So this is the let's look, medyo complicated sad gamay iyang base driver circuit, no? This circuit na naka-encircle, this alone is just the driver, no? So ultimately, ang kuan lang gid ani class, no? If medyo confusing man ang pag-tanaw lang alone sa atong circuit, one thing to remember is the purpose of this one is para paspas ang transition, no, from on to off. Mo gyud, no? So that fast ang transition from on to off and vice versa sa base. And because of the presence of reverse currents, which is inevitable na naman gina-perme, no? So during the on nga state, no, or during the time nga the base will give current before the current, no? So wala siya normal, no? Normal nga kuan. So sa may operation ani be, dali naman ni siya, dali naman subayon yun, no? PNP niya siya, so wait. Bahala ka nga transistor lang, no? At least masubay na to. When T1 is switched on, okay, so pwede si T1 is maybe regular lang na siya nga transistor, no? So regular lang, pwede po nga dili na to i-connect gyud ang atong sensor, no? Or whatever sa T1. So when T1 is switched on, T2 is driven. So kung si T1 is switched on, if T1 is on, so na current mag-flow. So if na current mag-flow away from the base, and because this is PNP, current will flow, no, from emitter to collector. And thus will turn on our TP. Forward bias man si D1. Yeah, so, muna may tabo, no? Kung usbo na to, when T1 is on, current will flow from its collector to emitter. And yung collector is naka-connect man sa base ni T2. So, na current mo hawak kay base ni T2. And because of that, na forward bias or na turn on si T2, yung kuan, no? Yung state. So, current will now flow from the emitter to the collector. Turning D1 or diode D1 on, forward bias siya. So, triggering, no? Triggering TP. When T1 is switched off, this time, if T1 is switched off, so wala na yung current mag-flow kay collector to kuan. So, parela, no? Kung if T1 is switched off, wala na yung current mag-flow. Thus, T3 will be switched on then, no, this time. So, if wala yung mag-flow ng current, so si T3 na sad ang ma-on, no? So, if T1 is off, si diode 1 is na reverse bias. So, kung reverse bias siya, allowing T3 to be on. No? So, nanay current pong flow from the emitter to collector ni T3. So, yeah, allowing for the excess reverse current ni TP to flow to T3. Yan na. So, mapapaspas ang pag-change yung state ni TP from on to off. Kinamantay agianan, no, sa tong current because of T3. So, kung ito i-summarize, ang kanina driver circuit, no? Ito i-summarize. So, si TP mo na itong gusto gili ko, ano? For TP to be on, T1 should be on. In turn, si T2 sad. Of course, si T3 off. Or off pa. So, ang current is mag-flow dito. Okay? Forward bias. If we want our TP to be off, okay? So, i-off na si T1 and i-off si T2. Dili na dayon ang difference between irregular na BJT and a power BJT. Because of the presence of T3, when T1 and T2 is off, T3 is on. On si T3. Allowing for current to flow from the base of our transistor in question to flow to T3. So, yan na lang, no? Simple na kayo ang operation. Dali na ito masubay. Pero, basta makayunta nga, redundant siya. Nung anong butangan pa man yun o driver nga circuit, again, so that pas faster ang transition from on to off ni BJT, TP. Okay. Perhaps si TP ang connected sa atong power circuit. No? Siya ang naay biggest need kibali to have a faster transition. So, this circuit will do. Kaning simple circuit. Kaning second circuit, the same na gyapon iyang main objective, no? Para paspas ang transition ni transistor TP. Okay? During one instance, only one of T1 and T2 will be on. So, the same na gyapon sa purpose actually. No? Para na ay pathway or gawasanan ang reverse current nga mogawas sa base during transition from on to off. Okay. Kani bitaw. Kani reverse current. We want that to be as narrow as possible. Okay? For that to be narrow, dapat na ay proper na driver circuit nga na-connect sa base. Okay, so actually, mula to ang iyang explanation. So these two are the most common power BJT applications. Kanilang duha, perhaps, because napa may mas powerful noon gyud nga sa semiconductor device to use in high power applications aside sa BJT. Oh, we have also the MOSFET, the FET, and the IGBT, the insulated gate bipolar transistor. So as for the power BJT, mo ni ang mga common applications niya. One is for the buck boost converter. So this is the buck boost converter. And in this case, the BJT is used as a switch. So, sige lang ha. Don't worry kung how a buck boost converter works. Muna itong mga next na mga topics. But yes, here, ang BJT is isa sa iyang mga switching circuit. Another one is a chopper. A chopper driver. Chopper is another term if ang load is a DC motor. So the BJT here acts as the chopper. So again, kani, di pa nato ni ma-cover yun how this whole circuit works. Kaya puon pa ni siya after pa siguro sa buck boost. After pa siguro sa mga converters. But again, here, the BJT could be used as a chopper. Okay. So I guess that's it. Mas ma-appreciate siguro nato ang kaninga mga concepts when we go to the discussion of MOSFET and IGBTs. Kana mas kuan man sila, okay? Di ko siya mag-na-com sa inyo gyapon na-cover mo sa gyapon niyo sa inyong notes. Mas better in some regard, mas better sila gamitan. Especially ang IGBT, Especially ang IGBTs. Kung ako lang ang opinion, ang iyang operation kay partly BJT, 50% BJT, 50% FET. Mga siyaging ana. And at least ang IGBTs is solely for power, power applications. Wala po ko kabantay or kita og IGBT nga kanang discrete component bitaw nga pwede ra sa breadboard. So next meeting na to ni siya ma-discuss kaning MOSFET ug IGBT. Okay? So in conclusion or in summary, the power BJT works in the same lang gid nga manner, to that of a regular na BJT. But aside lang sa iyang high power na mga capabilities, it could carry high voltage, high current, mga high thermal mga characteristics. Iyang main feature is this one, the presence of the collector drift region. The lightly doped region sa collector side. And because of that, it paved the way for the quasi-saturation region. The quasi-saturation region is there so that we could have a much faster transition from cut-off. So instead of cut-off to saturation, cut-off to quasi-saturation. And we know that faster transition results to lower power losses. Okay? So, higher transition, lower power losses. Okay? Always remember this one. Pag nato siya madumduman if makita nato ni nga graph. Kani oh. Common man ni siya sa I think common ni siya sa halos gid tanan, no? If dili man ganit tanan na power semiconductor devices. Dili nato makita kung asa na portion siya ga consume og power, no? It's only during transition. Okay, multiply na to ang IC and VCE during only IC off si IC, zero man siya, no? Zero. Kung balipod, multiply na to si zero IC and high VCE, zero gyapon. So ayaw lang gid siya maka-cause og power loss during transition. And because of the quasi-saturation region of the BJT, it allows for a much faster nga transition. Okay. Kanay sa safe operation areas, dali na siya. This could be observed, no, or pointed out sa specification sheets. Naman na siya sa specs. Okay, and well, kung mag-search ta sa internet og mga daghang klase nga mga base driver circuits, hindi dito makita, no? These two are just the simplest ones that I could give. Kaning duwa. Again, ang purpose lagi ani again is to kuan agad, no? Basic gihapon nato nga kuan nga objective para mas pas nga transition from on to off. That's the reason why there is a more sophisticated na base driver circuit nga i-feed sa power transistor compared to the regular nga transistor nga wala. Alright? So that ends our discussion for this afternoon. Any questions? Mata pa mo guys? Are you still there? Apa. Okay. So sabtan na, no? Dagan kay itong storya, pero ang bottom line lagi nato ani. Sige lang, ma-review naman po niya sa YouTube. Ang bottom line lagi ani is i-minimize sa gyud, no? Ang power losses. And that could be minimized if faster ang transition. And sa power BJT alone, dagan siya og mga avenue, no, para mas mapapaspas ang transition. And mato na discuss kanina. Daghang mga options for us, no, to lower down or to increase the transition from on to off or off to on sa power BJT. Okay? Lang. For next meeting, padayon ta with power MOSFET and power MOSFET and IGBT, no. Kaya ang IGBT man yun, power man gina siya, yung application, no. Tapos yun as inyong notes, no, naka-note mo siya mo daan ana, ay MOSFET o IGBT. So try to review it. Panahon sa difference niya, no. Kung i-compare sa regular MOSFET, kung i-compare na to ang power MOSFET o power BJT, no, sa ilahang similarities o sa ilahang differences. And kinsay mas better, no? Kinsay mas better na kuan na switching device. Malabitog as if ang atong subject ay the search for fastest power electronic switch. Magmalagid, no? Kaya kung pohon, mabot mo sa ingani nga kuan, sa ingani nga field, mao magid iyang kuan, no? Mao magid iyang atong kuan objective. Kasi pinakapaspas nga switch available. Any more questions? Wala na ko to gihatag nga analogy ha tungod kay nang tanaw taog kan gabi eh. O katong pinaka-trending nga phenomenon sa Facebook gabi eh. Mo sige mong manok nil no. Ako na ni ko na. I-off na kung record pala. Para off the record na ta. Dahil kababayan dito nimo. Taga Cebu gid ka originally nil. Ano naman kay Bisaya. Film story mo pasabot okay. Kano pa mo nabasa ang kwan. Kano pa na nabasa ang chat. Sayang to si Miss Orba. Sayo kayo natagak. Dunggan di ay. Kuha na ko kay Peanuts. Na-prove na gid nako, Job, nga malag dihado gid sa signal dito sa tua. Po kasulay nga si kaputol ay. Ito na ako dito sa balay. Sinay pag yun. Globe inyo dia. Globe ang mo ang connection dito. Di kuan man amot lang ha. The same gyapon sa katong akong previous nga gina-stayan sa PLDT. Paspas man siya, no? Mas paspas pag akong connection dito kaysa dili sa balay sa nakauli naman ko kagayan ron kaysa dili sa balay karon. Pero ako mabantayan kasi kato sige ka putol, no? Sige ka di reliable gihapon. I don't know. Ano akong na-notice. Mas akong kuan. Lagi ka na, no? Sige ka putol. Okay lang ba kung YouTube or sa ba Netflix nga dili bitaw need og reliable na connection, okay ra nga. As long as naka-load na daan, enough naman na. Pero kung yan video call, inang lang yun, og balag di kay paspas bitaw balag medyo hinay. Sa reliable lang, di lang kayo, di lang maputol-putol. Ang importante. Sila mabot po ng 5G. Kasi kung ako nga pamis ang mahatag sa 5G. Naanad na. Sige lang, kaya isa to nag-forward, ako kung suto naka-forward, no? Na yung mga dungog-dungog nga, na memo ang CHED nga, na-approve na, na go signal for face-to-face for engineering. Di ay, maskin Google Drive nga videos, kinanglan dili putol-putol. Habot ka ng kuan. Off naman sa atong kano. Pero habot ka ng Zoom, mag-record lugar mo Zoom. Pwede ba maka-record nga offline? Like gigamit ni mo siya as app then dili bitaw cloud nga recording malag sa computer nga recording. Pwede ba yung ana? Patry mo ana. Or kung mag-record mo kay sa Google Meet. Ano ba ito? Gi-use si Zoom as recorder, no? Even offline. Yan. Wala nung kukatayan na. Try na ako later kung pwede ba. Kaya ka ng group reporting. Kaya naging group reporting, malag go-to gina siya ng activity. Nag-apply ko na before nga, i-require na ako sa estudyante po. Pikas mo itong klase. Pati ang putol-putol, ma-record, no? Well, anyway. Naday ko question. It's ito before tong ikaw ba to, Clark, katong nagpila o galauna images kadlawon para Comelec?
Yes, sir. Alas
Yeah,
3 to, sir.
Alas 3? Unya, gi-kuan man, gi-extend.
Lagi, sir, magbalik ata ko next month, October naman di karon. Try lang nako, sir, if check nako if task gap na niya. Kaya wala social distancing, sir. Hindi ka na po, ma'am.
Lagi? Naubos na ba ang cases sa Cagayan? Basig tungod ato bitaw.
Lagi, sir, di pasad ko vaccinated, sir, kaya basta di gana na po.
Lagi. Basig risk na noon siya.
Partida,
may tabo.
sir.
Basta to? Partida kay?
Partida, sir. Walay social distancing. Pero niabot og get kayang linya. Unsa na lang ako nag-social distancing.
Mas taas palagi daw ang pila sa kuan, no? Sa Comelec kaysa kuan, kaysa vaccine.
Isa sad ka year, sir, no nga walay nagpa-register, sir, no? Isa ka year? Or do?
Noon. Kuan.
So,
Mag-open man gyud siguro na whole year round after election season, pero well, you know, nabiya kita. Kahit magkuan ba sa last minute na. Mamahita po bitaw na. Mingaw na po na siguro for next week and next week. Dito gyapon na magdagsa ba sa end sa October. Nako. Na-extend bitaw. Bitaw. Sige, kuan sa ta, no? Break sa tagamay, 5 minutes before logic. Then, balik ta sa next channel. Okay? Next channel, next room. No, next room. Sige. End ako niya. Wala na questions? Concern?
wala na, sir. Bye, sir.
Sige. Snacks up mo.
Okay, sir. Happy eating, sir.
Sige.
Kapi-kapi sa ta, sir.
Sige.